Why waste time in commute and spend a lot of money for NEET UG coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. NEET UG. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the PYQ discussions on JEE Advanced papers. Here I have got a problem from JEE Advanced paper 1 2022. The problem says at time t is equal to 0, a disc of radius 1 meter starts to roll without slipping on a horizontal plane with an angular acceleration alpha is equal to 2 by 3 radian per second square. A small stone is stuck to the disc. At t is equal to 0, it is, that means the stone is at the contact point of the disc and the plane. Later, at time t is equal to square root of pi second, the stone detaches itself and flies off tangentially from the disc. The maximum height in meter reached by the stone measured from the plane is half plus x by 10. You have to find out the value of x, where g is given as 10 meter per second square. So let us first try to understand the problem. The problem says there is a disc which starts rolling over the horizontal plane with an angular velocity omega. So that is happening at t is equal to 0. Okay. The disc has got 1 meter radius and it starts with an angular acceleration 2 by 3 radian per second square. So initially actually it doesn't have any angular velocity. Okay, that is the situation we can take here and see at t is equal to 0, the stone which was stuck to the disc was here at the point of contact between the disc and the plane. But as the disc rotate or rolling means it will be rotating as well as it will move in the forward direction. Let us say the center of mass of the disc is moving with velocity v. This is the linear velocity and this is angular velocity. Because of this rolling, this point, so every time the point of contact will be changing. Okay, that means this point will go somewhere here and this point will come to here. Okay, this point will come to here and this bottom point will just rise up to some height. Okay, so after time t is equal to 0, suppose this stone comes here somewhere and it flies off from the disc tangentially. Okay, so this is the situation given. Now if we have been given the alpha and this is a constant term, we can actually use the kinematic equation to find out the omega, taking the initial velocity, angular velocity to be 0. We will be getting angular velocity after t is equal to pi as square root of pi as alpha into t. Therefore this omega will be 2 by 3 square root of pi, and this is actually rad per second. Okay, now as I said, so this point will just move to somewhere here after time t is equal to square root of pi second. But what is this angular displacement? Can we find out from kinematic equation with this alpha? The answer is yes. So theta will be is equal to half alpha t square. That means alpha is 2 by 3, half is this, and t square means pi. So this will give you pi by 3, that is 60 degree. Okay, that is 60 degree. That means this will be the situation after t is equal to pi second. The angular velocity is given as two by 3 root over pi second. Okay, and also we have got the angular displacement. Here look, when this stone reaches up to here, that means it has actually is raised to a certain height compared to this plane. Okay, and after this point the stone will be actually flying off from the disk. Okay, and this is the supposed translational velocity of the center of mass v, and at this particular point what will be the velocity tangential to the disk? That will be omega into r. Okay, because the disk is rolling without slipping, I can write v is equal to r omega. So that's how I get the tangential velocity. Now see the situation here. This angle we have found out to be 60 degree. Okay, so this is where my stone is now. So this angle is theta degree. Now the force tangential to the stone is this one, omega r. If I draw this perpendicular, so this 60 degree, so this also will be 60 degree. Therefore there will be two components of this omega r. This will be r omega sine 60 degree, and along this way this will be r omega cos of 60 degree, right? And also there will be a velocity in the horizontal direction, that is v. So these two velocities are not important while calculating the height reached by the particle after it is flying off from the surface of the disk. Okay, so I have got here r omega sine 60 degree. So sine 60 degree is actually square root of 3 by 2 into r omega. So this will actually be the initial velocity while leaving the disc by the while the stone leaves the disc surface. Okay, this will be the initial velocity. So if I want to find out the height finally reached by the stone, before that we have to actually find out this height, okay, from the ground. So this height will be nothing but A is equal to, so this is r cos theta, so r minus r of cos theta. If this is r is the radius, okay, r minus r cos theta. And see this cos theta, theta is 60 degree, so this is r minus of r by 2, which is r by 2. That means this h is equal to r by 2, that we have got. Now it has got certain tangential velocity, so that will, yes, there is a tangential velocity which has a component along the vertical direction which will drag the stone up to certain height. We have to find out that height. So how do you find out that height? That we can find out writing, see, final velocity will be 0, right? So v square is equal to u square minus 2gh taking that formula, okay. So that will be, suppose this is h1, 2g h1. So from here this is 0 final velocity, so h1 will be u square by 2g. So u is here, this is 3 by 4, and this is omega square r square divided by 2g, okay. So here omega we have found out already, r we know. So from here actually see this h1 will be able to find out. So 3 by 4 into omega square means 4 by 9 into pi. And what is r square? R square is actually 1 meter square. That is what we know, right? For the problem, yes, 1 meter. Divided by 2 into 10, okay. Now if we simplify, what we are going to get here, so this is 3, this 4 goes off, then I'll get here pi by 6 into 10, okay. That is what I'll get here. Now look, if I come here, see the total height will be capital H. So total height reached by the stone will be this h plus h1, okay. So h is actually half, because this r is 1 meter, half plus h1 is pi by 6 into 10, okay. So here in the given problem it is see x by 10. Okay, look this, height reached by the stone is measured from the plane, and that is found to be half plus x by 10. So if I compare with this, we have got h from the plane as half plus pi by 6 over 10. So this x, this is the value of x if we compare with the given expression for the height. So we get x is equal to pi by 6, and this is the answer for the question. Thank you.
Why waste time in commute and spend a lot of money for IIT JEE coaching? Parents, do you want your kids to achieve top scores in IIT JEE? India's leading online NEET coaching 100% success IIT JEE. At TeenEinstein, we focus on IIT JEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.